Hi guys, in my last video we looked at horizontal projection. So if you shot something off in a horizontal line and then it fell as it was going along. But obviously that doesn't happen much in reality. Often you're looking at shooting up at an angle for it to come back down. Certainly say you were working on a battleship and you were looking for a long range missile, you would shoot it right up in the air and expect it to come down on your target. So you tend to project things off at an angle. Now there are two different ways which we could represent that angle projection, and the first one is by looking at its speed as it's going off. So let's put that at 5 meters per second, and also then at its angle 60 degrees. So U is equal to 5 meters per second, but because we've got that whole idea of the force, the only force that's acting on the body is its weight when it's in this direction, and weight acts directly down, there's no horizontal force. It's very useful to split the horizontal and the vertical components of any vector quantity up, because that makes things much more helpful for us. So I'm going to split this up into a horizontal initial velocity and a vertical initial velocity. So I'm going to put in a triangle here, and that would be ux, and this would be uy. So ux, see, I would be utilising cos, would be 5 cos 60, and uy would be 5 sine 60, which, as they are ones that we know, we might as well work them out. Cos 60 is a half, 5 cos 60 would be 5 over 2. And sine 60 is root 3 over 2 times 5 would be 5 root 3 over 2. Now we could put that into a vector form. So I could call u as a vector, and that would be 5 over 2 I plus 5 root 3 over 2 j. Or if you're more comfortable with column vectors, which sometimes I am, sometimes I'm not, I might write like that. So I think that makes sense in terms of, if you know its velocity and the angle that it's going at, or its speed and the angle that it's going at, then you can put that into a vector. And obviously we've got, in component form, we've got component form of the, we've got horizontal component of the initial velocity and a vertical form of the initial velocity. Well, let's say we were given the vector form. So say we had five I plus 7j. So what we're saying there is that our vector u is made up of going 5 in that direction and 7 in that direction. So it's only just simple GCSE maths then to find out what the scalar form of u is. So u would be equal to, utilising Pythagoras, 5 squared plus 7 squared, which would be the square root of 25 plus 49, which is the square root of 74, which would be root 74 is 8.60. And if I put my angle in there, so my angle of projection, theta, so theta would be equal to the inverse tan of the arctan of 7/5, which would equal 54.5 degrees. And I think we do tend to work with degrees mainly in this. So what you can tell then is that the object is being projected with an initial velocity of 8.6 at an angle of 54.5 degrees. So it's just really working backwards. Here we started off with a projection and with a velocity and the angle, or even a speed and the angle, and we worked to find in the vector form of the velocity. Here we started off with a vector form and then we worked towards finding the speed and the angle in that respect. So finding the vector, undoing the vector, really, and it's things that we've done lots of times before, so hopefully you'll get it quite nicely.